The general solution is required if either it's asked for, or solutions are required outside the primary interval, so primary interval being 0 and 360, or the angle is in the form of n times theta, where n is not equal to 1. Solve the equation sine of x equals 0.5878 for x values between minus 720 degrees and 720 degrees inclusive. Give your answer to the nearest degree. So we're interested where sine is positive. Sine is positive in the first and second quadrant. So again, we follow CAST. So we have sine is positive in the first quadrant, sine is positive in the second quadrant. In the second part, we can stop writing down additional angles when we can see that the values are outside the stated interval. So we have sine of r equals 0.5878, and the inverse of that is going to be 36 degrees. So the reference angle is 36 degrees. So in the first quadrant, the angle itself is equal to the reference angle. So the first quadrant, x is 36 degrees. And in the second quadrant, it's going to be 180 degrees minus the reference angle. So in the second quadrant, 180 degrees, take away 36 degrees is 144 degrees. So we get x equals to 36, 36 plus or minus 360, 36 plus or minus 720, Our x is equal to minus 684 degrees, minus 324 degrees, 36 degrees, and 396 degrees. Or x equal to 144 degrees, 140 degrees plus or minus 360 degrees, 144 degrees plus or minus 720 degrees. So x is equal to minus 576 degrees, minus 216 degrees, 144 degrees, 504 degrees. Find the general solution of cos of 3 theta is equal to minus a half, and use it to find all the solutions for theta greater or equal to 0 degrees, less than or equal to 360 degrees. It's important to note that cos is minus here, negative, and cos is negative in the second and third quadrants. So second and third quadrants, cos is negative. So we're going to add n times 360 degrees to each solution in the primary interval before simplifying the angle. So we have cos of our r, which is our reference angle, is equal to positive a half. This minus needs to become a positive. And the inverse function of cos times a half is 60 degrees. So the reference angle is 60 degrees. So we're interested in the second and third quadrants. So in the second quadrant, it's going to be 180 degrees minus the reference angle. So we got 180 degrees minus 60 degrees is 120 degrees. In the third quadrant, the angle is going to be 180 degrees plus the reference angle. So 180 degrees plus 60 degrees is 240 degrees. So we get 120 degrees and 240 degrees. So 3 times theta is going to be 120 degrees plus n times 360 degrees, or 3 times theta is going to be 240 degrees plus n times 360 degrees. So therefore theta is going to be 40 degrees, because 120 divided by 3 is 40 degrees, plus n times 120, because 360 divided by 3 is 120, or it's going to be 80 degrees, because 240 divided by 3 is 80 degrees, plus n times 120 degrees. So when n is equal to 0, theta is 40 degrees or 80 degrees. When n is equal to 1, theta is 160 degrees or 200 degrees. When n is equal to 2, theta is 280 degrees or 320 degrees. So the solution set is 40 degrees, 80 degrees, 160 degrees, 200 degrees, 220 degrees, and 320 degrees. Show that the equation 2 sine squared theta is equal to 3 times 1 plus cos of theta can be written as a quadratic in cos of theta. Hence, find all the solutions of this equation for theta greater or equal to 0 degrees, less than or equal to 360 degrees. So we're going to use the trig identity. Cos squared a plus sine squared a is equal to 1. And we can rewrite this as sine squared a is equal to 1 minus cos squared a. So basically just bringing the cos squared a over the equal sign, it becomes a minus. So using cos squared a plus sine squared a equals 1, we get sine squared theta plus 1 minus cos squared theta. So we're told in the question that 2 sine squared theta is equal to 3 times 1 minus cos of theta. So we're going to swap sine squared theta for 1 minus cos squared theta, because we got that over here. And we're going to multiply out the brackets. 3 multiplied by 1 is 3. 3 multiplied by cos of theta is 3 cos theta. So we get 2 times 1 minus cos squared theta is equal to 3 plus 3 cos theta. So then we're going to multiply out these brackets. 2 multiplied by 1 is 2. 2 multiplied by minus cos squared theta is minus 2 cos squared theta. And then we bring this down. Next, we bring everything over the equal sign. So we bring down the 2, the minus 2 cos squared theta. The 3 comes over, becomes minus 3. The plus 3 cos theta comes over, becomes minus 3 cos theta. And this is all equal to 0. Next, we simplify. We bring down the minus 2 cos squared theta. We bring down the minus 3 cos theta. And then 2 minus 3 is minus 1, and this is all equal to 0. We multiply across by minus 1 to make this positive. So we get positive 2 cos squared theta plus 3 cos theta plus 1 is equal to 0. Next, we factorize. So we're going to bring down the 2 cos squared theta and bring down the plus 1. And then we need to break up the 3 cos theta into 2 terms. So 2 multiplied by 1 is 2. So we have to get factors of 1 and 2. So 3 cos theta is going to break down to be 2 cos theta plus 1 cos theta. Because 2 multiplied by 1 is 2, and 2 plus 1 is 3. Next, we're going to factorize the first 2 terms. So we have 2 cos squared theta plus 2 cos of theta. So we're going to take out 2 cos theta as the HCF, the highest common factor. And 2 cos theta divides into 2 cos squared theta and leaves us with cos theta. And 2 cos theta divides into 2 cos theta once. So we get this. Next, we factorize the right-hand side. 1 cos theta plus 1, the HCF is 1. 1 into 1 cos theta leaves us with cos theta. 1 into 1 leaves us with 1. So we get this. We notice we have the same thing inside both sets of brackets, cos theta plus 1. So that becomes one of our sets of brackets. We bring down the 2 cos theta and the plus 1. That's in the other set of brackets, and that's all equal to 0. We let each of our brackets equal to 0 and then solve for cos theta. So cos theta plus 1 is equal to 0. So cos theta is equal to minus 1. Or 2 cos theta plus 1 is equal to 0. So cos theta is equal to minus a half. So cos of theta equal to minus 1. Theta is going to be 180 degrees. So we know whenever we have 1, minus 1 or 0, we're just going to have the one answer. So we get theta to be 180 degrees. Next, we have cos theta equals minus a half. So we know we're going to have 2 answers in the primary interval. So we have to change this minus to positive. So we take the modulus. So we get the inverse function of cos times a half equals 60 degrees. So 60 degrees is going to be our reference angle. Remember, cos is negative. So we're interested where cos is negative, and it's going to be in the second and third quadrant. So in the second quadrant, it's going to be 180 degrees minus the reference angle. So in the second quadrant, 180 degrees minus 60 degrees is 120 degrees. So we get theta equals 120 degrees. And in the third quadrant, it's going to be 180 degrees plus the reference angle. So it's going to be 180 degrees plus 60 degrees, which is 240 degrees. So theta is also equal to 240 degrees. So the solution is 120 degrees, 180 degrees, and 240 degrees.